All right, let's get right into it. If you're a C# developer, you've definitely faced this question: abstract class or interface? In this explainer, we're going to break down these two powerhouse tools for abstraction, so you can start building better, more flexible code like right now.
When you boil it all down, the choice really comes down to this one question. Are you trying to build a foundational blueprint for a whole family of related things? Or are you trying to set up a strict contract that a bunch of totally different things have to follow? How you answer that? Well, that's pretty much everything.
And the one big idea that powers both of these is abstraction. Seriously, in programming, abstraction is just a fancy word for hiding all the messy, complicated details of how something works and only showing the parts you actually need to use. It's what lets us build these huge, complex systems without our brains exploding.
Okay, so let's tackle our first tool. Let's talk about abstract classes as the master blueprint. Their whole job is to set up a common structure and some shared behaviors for a group of classes that are all very closely related. The best way to think about this is with the animal kingdom. An abstract class is like the general idea of an animal. You can't just, create a generic animal, right? It has to be something specific, like a cat or a dog. The abstract animal class is the blueprint that says what they all have in common, but still leaves room for what makes each one unique.
So, what is it technically speaking? It's a special class, you mark it with the abstract keyword, and it acts as a blueprint. But here's the golden rule, the most important part. You can't create an object directly from it. You can't just type new animal. Nope. It has to be inherited by a more specific, concrete class first.
And this is where things get really cool. Abstract classes can have two kinds of methods. First, you've got abstract methods. Think of these as chores on a to-do list with no instructions. Any class that inherits this blueprint must provide its own way of doing it. But they can also have concrete methods. That's code that's already written and works, and every single child class gets it for free. It's this mix of you have to do this and hey, I already did this part for you that makes them so powerful.
And check out how this works in practice. The animal blueprint here says that all animals have to have a way to eat and make sound. But how they do it, that's up to them. That's why the dog class has to come up with its own woof sound. At the same time, the blueprint can give them some shared behavior, like sleep. In this case, every animal gets the exact same sleep method, which saves us from having to write that code again and again and again.
Okay, we've got the blueprint down. Now let's completely switch gears and talk about our second concept, the contract. You'll know it as the interface. Forget about shared DNA or family trees. This is all about creating a standard set of rules so that completely different, unrelated things can all work together smoothly.
And I've got the perfect analogy for you. A USB port. Think about it. You've got a mouse, a keyboard, a printer. They are totally different devices. They share zero blueprints, but they all plug into your computer and just work. Why? Because they all agreed to follow the same USB contract. That is exactly what an interface does in your code. Now, the most crucial thing to get here is that an interface is a pure contract. It is 100% focused on what a class has to do, and it could not care less about how it does it. It's just a list of method names. That's it. Zero code. It's just a list of promises that a class has to keep if it wants to play. This is where interfaces give you just incredible flexibility. Look at this robot.
It's one thing, but it might need to fulfill a bunch of different contracts, right? It might need one contract for how it gets power, another for how it talks to the cloud, and a third for managing its battery. And here's the absolute game changer. A single class can implement multiple interfaces. Unlike an abstract class where you only get one parent, a class can promise to follow many different contracts at the same time. It makes it unbelievably versatile.
And this shows you that contract in action. The contract is simple. It just says, look, if you want to connect, you have to be able to plug in and you have to be able to cycle data. That's it. So both the printer and the mouse agree to this contract. They are completely different things, but because they both honor the same set of rules, the system knows exactly how to work with both of them.
All right, we've defined the blueprint, we've defined the contract. Now for the main event, the final showdown. This is the practical, no-nonsense guide you've been waiting for. When do you use an abstract class, and when do you reach for an interface?
Okay, let's make this super simple. On the left, with the houses, you use an abstract class when you've got a bunch of closely related objects that all share some core functionality. Think of different models of a house that are all based on one master blueprint. You want to share some of the code, but force other parts to be custom. Now on the right, with all the different gadgets, you use an interface when you have totally unrelated objects that just need to share a capability. A car, a camera, a robot, they have nothing in common, but they might all need to be, say, irreparable. It's a contract, not a family tree. And that gives you incredible flexibility to just mix and match capabilities.
So, what's the big takeaway here? What do you walk away with? It all comes back to really understanding and using the power of abstraction. Getting this difference isn't just some academic thing to pass a test, it's a fundamental skill for writing clean, professional code. Because every single time you make that choice, every time you stop and think, okay, do I need a shared blueprint here or do I need a flexible contract? You're not just banging out lines of code. You're actually designing a system that's way easier to maintain, to adapt, and to grow. You're building for the future, not just for what you need today. You know, this quote from our source material just hits the nail on the head. Mastering abstraction is what separates a coder from an architect. You stop just making things work, and you start designing systems that are truly adaptable and ready for whatever crazy feature request comes next.
So the question isn't really which one's better. That's the wrong question. They're both fantastic tools. The real question is, for you, now that you know the difference between the blueprint and the contract, what amazing thing are you gonna build?